We'll see common collector configuration. Common collector configuration. So in this, collector will be made common to both input as well as output. Same thing, whatever you have written in base, same thing has to be written here. And then you have to like draw the input and output characteristics. We'll just do it quickly. Same theory part, whatever I have written in common base, just write down that. And here also we are going to take NPN transistor itself. So what are we making common? So emitter is made common. This is your emitter, this is your base, and here it goes the collector, right? So, and always remember that emitter base junction will be forward biased, and the rest is like, this is N, this is P, and this is N. Again, P is connected to positive, means it's a forward bias. So here we are going to give the input. Then we are going to give the input, and this is your output. So what is the theory you are going to write? Two terminals are needed for input and two terminals are needed for output. So basically transistor has three terminals, base, emitter, and collector. And in common collector configuration, what are we going to do? We are going to, common emitter. It's not collector. I'm so sorry. So this is a common emitter configuration. So emitter will be made common to both input as well as output. Right. So this is the figure. Now, what will happen whenever you apply some voltage? What will happen? Holes will be there in P type. Slowly, they'll move to N type. Okay, and only few will combine, and rest all will go to the collector. So let us quickly draw the input characteristics. So input characteristics are drawn by taking input characteristics are drawn in between input current and input voltage. What is the input current? IB. Input current is taken on y-axis and input voltage VBE is taken on y-axis. And what is kept constant? Output voltage is kept constant. So what is output voltage? VCE. No, VCE is kept at 0 volts. So you'll get a curve like this. So if VCE is kept at 20 volts, you'll get a curve like this. You observe that curve is shifting towards right side. And also, what is kept constant? Output voltage is kept constant. I'm going to increase VBE, keeping VCE constant, and IB is noted. So that everything has to be written. Next is output characteristics. So what are the output characteristics? So it is drawn in between output current and output voltage. If you see, output current is collector current, no? IC, right? And what is the output voltage? VCE, no? Collector and emitter, right? So let me just draw that. Output current is taken on y-axis and output voltage is taken on x-axis. And what is kept constant? Input current will be kept constant. So that is, that's IB. So you get a curve like this. So this is the curve you're going to get. And here also same like what we have done. So this is your base. No, base is 0. Next is base is equal to 10 microampere. Next 20 microampere and so on. 30 microampere. So here also you will have three regions. First is saturation region and another is cutoff region and another is active region. So in active region, you see that the curve is almost flat. No? And in saturation region, both the junctions, emitter and base are forward biased. And in cutoff region, transistor is in off position against. So this is about a collector, emitter. So what you are getting basically, you know that I is equal to IB plus IC, no? IB plus IC. Now you should write